Hello students, welcome to Sarasa classes. In today's lecture, I will be discussing the synthesis of carboxylic acids, and in the following part of the lecture I will discuss the retrosynthetic pathway of carboxylic acids. So over here, suppose this is our carboxylic acid. Question is, what are the starting materials from which this acid can be formed? Now carboxylic acids can be created via functional group interconversions, which include oxidations, B acyl substitutions, and a variety of carbon bond forming reactions can also be used to synthesize carboxylic acids. So let us now in a broad section discuss synthesis of carboxylic acids via functional group interconversion. Now, carboxylic acids can be formed by the oxidation of aldehydes or 1-degree alcohols using strong oxidizing agents. So, suppose we have taken over here a 1-degree alcohol, or we have taken a aldehyde, okay, and what will be the reagents that we can use to convert them into a carboxylic acid? That is this one. So we will list over here the reagents that one can use, which is obviously Jones reagent, or we can use KMNO4, or we can say any strong oxidizing agent can be used to achieve this oxidation. So what is our Jones reagent? Jones reagent is basically Na2Cr2O7 in presence of H2SO4, or we may use potassium permanganate, which is our KMNO4. It is important to mention over here that these reagents A and B can also be used to oxidize benzylic carbons to give benzoic acid derivatives. Okay, so what do I mean when I say this? Suppose you take toluene, or you take ethyl benzene, or you have taken benzene joined to a isopropyl group, or the benzene joined to CH2, which is basically called styrene. All of these can be converted to benzoic acid using the reagents A or B. Mostly for the practical purposes and easy to handle, we use A as the reagent. Important point to mention over here is that there should be a benzylic hydrogen present, at least one should be present over the carbon joined directly to the phenyl ring. That means if you were to take a benzene joined to tertiary butyl group, which is this compound, and we use the reagent A, then there is no oxidation taking place over here. Okay. Now, even alkynes and alkenes, especially those that are not tetrasubstituted, they will also give carboxylic acid products. When treated with KMNO4 under warm concentrated conditions, or by using ozonolysis with using oxidative workup for the alkenes. That means in these places we will not be using any reducing agents such as zinc or dimethyl sulfide or PPH3, that is triphenyl phosphine. So to summarize this in a reaction chart form, what we will say, suppose we have taken a alkene and we treat the same with ozone followed with oxidative workup. Then our products will be two different molecules of acid, because over here the alkyl groups are different. Or if we were to use the alkyne, again we use over here instead of H2O to the H2O, or one can think of using KMnO4 and heat, and then what we will get is the as carboxylic acids as the products. So this is two such synthetic procedures by which we can convert, as we have seen in the first case, that alcohols can be converted. So we will call this as one procedure, or aldehydes to carboxylic acids. Similarly, anything that is containing a benzylic carbon, so we are calling this as procedure 2, in which these can be converted to benzoic acids. And in the third procedure, we are invoking or using alkynes and alkenes and the following reagents that one may use to convert these into carboxylic acids. Thanks for listening. Keep visiting Saurabh's classes for the next part of the lecture. Have a great day.